Hey everybody, welcome to My Physical World. Today we are going to look at Landsat 8 images in ArcMap. The topic that we're going to be looking at is the flooding that's going on in Michigan, up near, well, not near, in Midland, Michigan. They had a couple dams that they call failures, but they're more like breaches. The dams weren't designed to take the amount of water that has been coming from the rains, so they breached the dams. The dams didn't actually disintegrate and fall apart. The water went over the top, even with the spillways fully open. But anyway, we're going to look at those Landsat images, but I want to show you how to get a Landsat image, how to create a band composite, and then view it in ArcMap and do some analysis with it. All right, so first of all, you need to go to USGS's Earth Explorer site, and it's really helpful. Obviously not helpful. You have to. You need to create an account. It doesn't cost you anything. You create a username and password, and then it gives you full access to the site to download all different types of data. Today we're concentrating on Landsat imagery. Landsat has been, it's almost 50 years continuous coverage of the Earth's globe. Landsats 1 through 8, with the exception of 6. Landsat 6 never made it to orbit. But we are currently using Landsat 8, and Landsat 9 will be launched hopefully in 2021. All right, so here we're at Earth Explorer, and I am interested in finding Landsat imagery for Michigan, actually up near Saginaw Bay. All right, so the first thing that you do really quick is you find the geographic location that you're looking for, and Midland, there's Midland, shows up right there, and this is the flood area right here. All right, so I want an image that gets me from this lake all the way down through Midland. So I'm going to kind of click in the middle. Hopefully that image is all one, 180 kilometers wide by 180 kilometers. So hopefully there's not a seam between flight paths. But tell you the truth, I already know it's all in one scene. We're good here. But sometimes you might have an image, a location that's split by multiple images. All right. In this case, we don't. All right. So I click the spot that I want my image, and then I come down here to the date range, and I'm going to choose anything from May 4th, 2020 to today, which is the 21st of May 2020. And then I'm going to go to my data sets, or their data sets, and we're going to come down here in this long list, go to Landsat, and then we're going to go Landsat Collection 1, Level 1. I can explain that in another video, but right now you want Landsat Collection 1, Level 1, and expand that up and choose Landsat 8. So put a check mark there. All right, so now you have the data sets that you want to look for, and then you're going to just click the results button. And it's going to go through and it's going to give you a list. Now normally these pictures right here, or where it says image not available, they must be doing some maintenance today or something like that, but you usually get a thumbnail of the scene that you're looking for. All right, and then you can click on it, and then you'll get a preview version of it. But in this case, there's some maintenance going on that these thumbnails aren't showing up. Now, I've already downloaded these today, so I'm not going to download, but if I wanted to download, for instance, I wanted May 4th, because that's before the flooding, and May 20th, which was yesterday, which was a great day for Landsat to go over that spot, which was absolutely amazing, which the flooding happened the day before and that day. All right, so to download, you're going to click this. Once you're logged in, you're going to go to the download options, and then you'll get this dialog here. I'm currently not logged in, but like I said, I already have these downloaded. So, but anyway, you want to select the GeoTIFF data product, and yeah, it's almost a gigabyte of data. This gives you all the different bands that are on Landsat. These other images, these are kind of cool if you're just doing some basic mapping. You can get the natural color like what you and I see with our eyes. You get the thermal image, and then you can get a conglomeration or a mixture of all of them. Okay, this 11.9 megabyte file is everything that you see above it. All right, but I always get the GeoTIFF data product, which is huge, but that gives you all bands of the Landsat image. So you click download, and then depending on your internet speed, you'll get a zip file or you'll get a tar file. If you you'll get a tar.gz file that you can unzip with any extraction software. All right, so that's all it is about getting images from Earth Explorer. Now, now you want to bring them into ArcMap. All right, what I usually do is there's different ways that you can bring satellite imagery into ArcMap. One of the easiest ways is basically you can just go, once you have that file unzipped into a directory, you can just go to add data. And here I'm in the 2020 directory. And if you'll notice that these are all the files that are in the zip file. These are all the different bands. So B1 is band 1, B10 is band 10, 11, 2, 3, 4, 5, all the way, all the different bands for the Landsat imagery. Plus you got the quality assurance TIFF, and you got some metadata files that come with it, some calibration files and things like that. But if you wanted to bring in this data, you can click each one of these TIFFs individually, and you'll have all the separated bands in your table of contents. However, we don't want to see them individually. The only ones I usually use individually are the thermal bands, 10, 11, and 12. Those are the only ones that I use them in their individual format. I'm sorry, 10 and 11 are the thermal bands. Because I might be doing something like for Yellowstone Park, and I want to see the temperatures of all the vents and geysers and stuff like that. So I'll bring up one of the thermals and show it in red, so I can highlight any heat signatures coming from the vents. But most cases you want an image that has all the bands together, that you can turn them on and off and create different combinations. All right. The easiest way, but it's not the best way, is if you notice this file right here, this rt.mlt.txt, and it has this little satellite image right here. If you bring this metadata file into ArcMap, it will automatically set up a band, a band composite, but it's not a physical composite. It is a virtual composite of all the different bands. All right. So we'll do that real quick. Hopefully real quick. It may take a little bit. So we'll add that MTL file, and it's going to add it to our table of contents. And if you notice down here, this percentage, I'm creating pyramids, which I can talk about in another video. But this is the process of creating those pyramids for each individual layer or each individual band. And I have a feeling that this is going to take a while, which I wish I didn't do that. Ah, okay. All right, so it's going through the bands here now. There we go. All right. Phew, that was close. All right, so it opens up, it creates a layer called Multispectral, and then the name of the file, and that name of the file means something. The most important is this line right here. This part right here is the date of acquisition. So it's May 20th, 2020. Okay. But anyway, you get this, it automatically creates a multispectral layer in your GIS. Then it gives you the picture of the image that you're interested in. Okay. And you can come into the different colors. Now this is visible: red, green, and blue. With Landsat imagery, you are mapping bands to visible light bands, if that makes sense. All right, so for instance, if I wanted to see infrared shortwave radiation, let's say band 7, and I want the software to show me that particular band in visible red, I would map it to the red. So for example, click on that little red dot, and I can click, let's say, shortwave infrared 2, which is band 7. I can click that, and it will map. If you notice our display changes over here, I've mapped shortwave infrared to the red visible light. Then for the green, I can map, let's say, the near infrared to the green. So our colors change here. Then I can map, let's say, visible red. I want to map to blue, to this blue color. And so our display changes again. So that's the easiest way to bring in an image for Landsat, and we'll talk more about playing with all the different bandwidths here in a second. But I want to show you another way, and this is the way that I use. I'm going to go ahead and turn this off, and I'm going to come over here to Arc Toolbox right up here in the upper right hand corner. I'm going to click that, and if you notice in Arc Toolbox under raster and raster processing, there is a tool called Composite Bands. We're going to double click that. And what Composite Bands does is almost the same thing in a way that are bringing this metadata in. It created a virtual multispectral image. Okay, if I close this out, I would have to repeat it to bring this image back up. I'd have to repeat that process of bringing this back up. Now, usually what I do is I create a brand new file. If you'll notice in this May 4th right here, I've already created one for the May 4th image. I actually have one for the May 20th image too, but I'm going to show you how to do this. But this May4.img is a file that is on my computer that has all the bands that I need to use for analysis. In other words, bands 1 through 7 is usually what I use. And because I gave it a file extension of IMG, it automatically converts this band composite into an ERDOS Imagine file. And I love ERDOS Imagine files because they're easy to work with, all right? So what we're doing here is in the composite bands, we're going to go to our open folder, and we're going to make our way to May 20th, which I did already here. And all you're going to do is you're going to click only the bands that you want to put into that image file. I want band 1, I want 2, 3, 4, 5, 6, and 7. So I want bands 1 through 7. I don't, band 8 is the panchromatic. I don't need that. 9 I don't need. 10 and 11 I like to work in separate files. Okay, so I want bands 1 through 7. So I select, highlight bands 1 through 7, and I hit add, and it's going to add them to our menu here. So these bands will be all combined into one image. And here this is where we name our image. So I'm going to click my folder, go to the directory, in this case, Michigan, all right? And I would click, I would name the file right down here, like May 20th.img, and that would automatically create a ERDOS Imagine file that I can work with. Now, like I said, I've already done it, and sometimes it takes a while for it to create it, so I already have a turkey in the oven that we can get right out and go to the next step. So here I would type in, for instance, May 20th.img and hit save, and then click OK on this window, and it would create that ERDOS Imagine with those 7 bands. All right, so I'm going to cancel out of that, and let's pretend I already did that, and I click OK, and it processes it, and then it adds it to our table of contents. So I'm going to cancel here. All right, so I'm going to get rid of the multispectral one because I don't need it anymore. And I'm going to add data, and I'm going to go to that directory that we just saved, the May 20th.img, and we're going to add it to our ARC session. All right, so now I have two layers, two images, sorry, 2 Landsat 8 images, one from May 4th, 2020, and one from May 20th, 2020. All right, now by default, it puts the layers in a certain order. All right, this is band 1, this is band 2, this is band 3. However, this band combination doesn't make much sense. Notice how blue and dark this map is. We want to see what this area looks like if we're flying over in the International Space Station. For you, we're gonna map layer 4, which is red light. We're gonna map that to red. We're going to map layer 3, which is band 3, we're going to map that to green. And we're going to map blue, which is layer 2. We're going to map band 2, layer 2, to blue light. This brings up an image that looks like if we were flying over this area in the International Space Station. All right, so this is natural. This is natural light. This is what your eyes see. All right, so now we're going to zoom in. Midland is right here, I believe. So we're going to zoom in right here, get a little bit of Saginaw Bay, and we're going to zoom into that area. All right, so here we have Saginaw Bay. Here we have Midland, Michigan. We have up here, we have Edenville. Down here, we have Sanford. All right. So this is showing you the geographic area that we're interested in. All right, now, a couple things in natural light. Sometimes you can see changes really well in natural light. Sometimes you have to play with the other bands to be able to distinguish what you're looking at. But if you notice, look in natural light. Now, here is May 20th. This is during the flood. This was yesterday. All right. Notice right here in the Saginaw Bay, you see this brown runoff, this silt, this sediment deposits being that are flowing into the bay. You can see them really well, muddy water, okay, basically. And if you look up this river right here, you're going to see that brown, murky water, okay? This is actually the flood water. And you can actually see it pretty well in natural light, okay? Now, let's take a look at what it looked like before the flood, okay? This image is a little darker, but not as much sediment is going into Saginaw. You don't really see the floodwaters along the river. Now, this lake here is a little murky, but that's deceiving because that's what your eyes see. What I'm going to do is I'm going to change the band combinations in these Landsat 8 images, so we can distinguish different reflectances or different phenomenon easier for you and I to recognize. All right, so we're going to go to May 4th, and we're going to do what is called a false colored composite. We are going to do band 7, which is short wave radiation into the red light. And we're going to band 4 to green and band 3 to blue. Here we are looking at infrared. And this band combination is useful, or do I want band 2? I want band 2, sorry. 7, 4, and 2. All right. This band combination is useful for looking at vegetation. Healthy vegetation shows up red. Non-vegetation does not show up in red. It shows up in browns and things like that. Okay? Actually, let's go back to band 3. Yeah, either one. They're not that much different. All right, so if I was doing a vegetation study, I would use this band combination. However, I'm interested in finding out the extent of the flooding. All right. Now notice that the sediments don't show up as well because we're using a lot of this band combination doesn't really highlight a lot of sediments. What we want to do is we want to use bands 5 in the red, which is near infrared. We want to show that in red. We want to map the shorter wavelengths of short wave radiation, which is band 6, to green. Now you're seeing some dramatic change. And then for the blue, I want to map red light into the blue light. Okay, so that was a subtle change when I did that one. So bands 5, 6, and 4 are primarily made for doing land and water analysis. Okay, now clear, clean water absorbs infrared light. So if you have clean, clearish, not completely transparent, but if you have clean, clearish water, it's going to always show up black or really dark blues. Okay, so if you look at these lakes, they show up black. Saginaw Bay it also shows up black and dark blues. All right. Now, notice that you're not seeing much sediment come out of here right now because the bands combination is optimized for land and water. All right. Now we're going to come up to, we're going to turn this one off. No, we're just going to turn May 20th on. This is May 20th in visible light, and we're going to change the bands to 5, 6, and 4 as well here. So we're going to go 5 red, 6 green, and 4 blue. No, whoops, 6 and 4 blue. Now you see a dramatic change. You notice the purple. All right, remember, clear water absorbs infrared light. So things show up black or really dark blue. However, sediments in the water, they reflect infrared light. So you get a different signature for that phenomenon. So here in this band combination, those sediments in the water show up purple. And any dirty, murky water shows up purple. So you can definitely see the floodwaters caused by the breach of the dam here, and then there's a breach of a dam up here. So this purple river is floodwater. And then here's Midland, and they're currently in flood stage right now in their city. They evacuated about 11,000 people in the past 12 hours. So if I turn off 20, you're going to see what it looked like before the flood. Okay? And then when I turn on 20, you're going to see what it looks like after the breach. Okay? Quite dramatic difference. Okay? So there's before the flood. There's after the flood or during the flood. And you can see the sediments pouring into Saginaw Bay from this river over here. Plus you see some flooding around Beaver, Michigan. Okay, and you can kind of see floodwaters elsewhere just because of all the rain that they've had in the past week. Okay, so Landsat imagery is a fantastic tool for, in this particular case, doing flood studies. Now, we can go in and do some classification. We're not going to do that because that's a whole video in itself. I can go in and tell the software to start extracting out all this purple stuff, okay? And it will go in and it will extract all of the pixels that have that purple color, and I can start doing calculations of how much surface water is out there, okay? What is the difference between a normal day and a flood day, and what is the impact in terms of, you know, some mathematical number, all right? And that's called classification, that you use Landsat imagery, okay? You can also use Sentinel imagery to do the same thing, but Landsat image has history behind it. We have almost 50 years of data with Landsat. Matter of fact, a few days ago, May 18th, was the 40th anniversary of Mount St. Helens erupting, and I was able to bring up images from pre-eruption and all the changes to the area since then for the past 40 years. Okay, you can't do that with Sentinel yet. Sentinel's not that old. But Sentinel's a great platform for doing stuff, current stuff, or the past few years. But if you want historical data, Landsat is the only way to go because it's the only group of satellites that have had this continuous coverage of the Earth. So I hope you liked the fast tutorage of using Landsat in ArcMap. Just so you know, our QGIS can do the same stuff. So if you're a QGIS user, which I am too, I use them all. I use all the GIS software out there. You can do the same stuff in QGIS. It just has a different process of setting it up. Okay, so this is ArcMap and using Landsat. So I hope you liked today. If you do, subscribe. Please subscribe to my channel and check out our Facebook page, My Physical World on Facebook, and like that page. And you can buy maps and books from me from MyPhysicalWorld.company.site. I have some maps that I've been making, and I'm making some wallpapers and stuff like that that you can purchase. And also, please consider becoming a Patreon and helping supporting my research. I hope you guys have a great day and stay safe, and we will see you later.